2-5, literal equations and formulas. So our objective here is in this section is to rewrite and use literal equations and formulas. And our essential understanding is that when you work with literal equations, you can use the methods you have learned in this chapter to isolate any particular variable you want. Okay, so what exactly is a literal equation? So in this lesson, you will learn how to solve problems using equations in more than one variable. A literal equation is an equation that involves two or more variables. So basically, all we're going to be doing, since we're going to have one equation and it's going to have two or more variables, is we're going to take that equation and just rearrange it. So with literal equations, we're not always solving for a particular number. Sometimes we're just rearranging equations to solve for a letter. Let's see what this looks like. So problem 1, rewriting a literal equation. So the equation 10x plus 5y is equal to 80, where x is the number of pizzas and y is the number of sandwiches, models something in a warm-up problem that we didn't look at. So how many sandwiches can you buy if you buy 3 pizzas? If you buy 6 pizzas? So what we're really looking for is we're looking for the number of sandwiches. So it would be better if I were to get y by itself, and then I could look at this problem a little easier. So if I start with my equation, equals 80. If I want to get y by itself, okay, well, I have to treat that as the variable that I'm solving for, and I want to get everything else out from the left side of the equation. So the first thing I'm going to do is I'm going to subtract 10x from both sides. But you can't subtract 10x from 80 because they're not like terms. So all I can do is leave them separated. Now I can divide everything by 5, everything, and I get y is equal to 16 minus 2x. So now I have an equation that's y equal to something, that sandwich is equal to something, and now it becomes a little bit easier to figure out what, when x is 3, what's y? So I can go y is equal to 16 minus 2 times 3, which gives me y is equal to 10. So if I buy 3 pizzas, I can buy 10 sandwiches. Okay, if x is equal to 6, then I can go y is equal to 16 minus 2 times 6. And when I do this, I get 4. Okay, so what do we do here? I took an original equation, I rearranged it to come up with a new equation that helped me solve this question a little bit easier. Let's look at our got it problems. So solve the equation. 4 is equal to 2m minus 5m for m. That's the variable I want to get by itself. So 4 is equal to 2m minus 5n. I want to get m by itself, so I isolate it. I add 5n to both sides. I cannot combine these two because they're not like terms, so I just leave it as 5n plus 4 is equal to 2m. Divide out the 2 from everything. I need a little more room here. Look at that. Okay, so now we have 5 over 2n plus 2 is equal to m. Okay, so what are the values of m when n is equal to -2, 0, and 2? Well, I can do, let's do n is equal to 2. So that's 5 over 2 times 2 plus 2 is equal to m. The 2's cancel because one's on the top and one's on the bottom. And we have 5 plus 2 is equal to m. So that's 7. When n is equal to 0, that becomes way easier because that term just cancels. So then m is equal to 2. And then, I did 2 first. Sorry. Let's go back and do negative 2. So that's 5 over 2 times negative 2 plus 2 is equal to m. And a little more room. These two cancel and reduce to negative 1. So that's negative 5 plus 2 is equal to m. So negative 3 is equal to m. Okay, so we have our 3 answers for these 3 situations. Now, you're probably thinking from this question that I had sort of been moving down a little bit, you're probably thinking, well, why do I need to do all that? Why can't I just plug in 3 and 6 into my original equation from the top one, into my original equation and just solve that? You can, okay, we can do 10 times 3 plus 5y is equal to 80. So that's 30 plus 5y is equal to 80. Subtract 30 from both sides. That's 5y is equal to 50. Divide out the 5, and we get y is equal to 10, just like we did up top. Okay? That's fine if you're only going to solve this problem once. All right? But since we're going to do this more than once, all right, it is helpful to get the y, or to isolate the variable that you are looking for first. Okay? It makes solving the problem slightly easier. Okay? Now, when you rewrite literal equations, you may have to divide by a variable or variables in the expression, and when you do so in this lesson, assume that the variable or variable expression is not equal to 0, because, of course, division by 0 is not defined. So we're just going to assume that when we divide out anything with a variable that is not 0. Okay? This is the more typical kind of literal equation problem. Okay? With this one, all right, whether or not this is more efficient than the way we did it down in the bottom in the got it problem, that's something you kind of have to look at and decide for yourself. Could be faster to just solve the problem. However, this question specifically asked you to solve for x, okay? And there's no numbers in the whole problem. All right, this is a typical kind of literal equation question that you would see on some sort of standardized test. Okay, so we have to get x by itself. So I have ax minus bx is equal to c. Well, I can't, if I add or subtract or something, I still have x's on both sides. That's not good. So I should use the distributive property. And in fact, if I use the distributive property backwards, I can factor out an x. And that leaves me with a minus b left over. Okay? Check yourself here. So if we multiply x times both of those, we get back to my original expression, which is good. They both have this x in common, so I can divide it out and put it in the front. Okay? To get x by itself, we're going to divide everything by a minus b, which cancels. So my x is going to equal to c over a minus b. And we're going to assume in this question that a minus b is not equal to 0. That's what we said in the previous page. Okay? Let's try a got it problem. Solve this expression for x. So we have minus t equals r plus px. Well, I only got x in one spot. That's good. Let's get it by itself. So first, subtract r from both sides. So that's a minus t minus r is equal to p times x. Then divide out the p. And we have a minus t minus r over p is equal to x. Okay? And then one more step that you could do but don't have to is to realize that both of these are a minus, so I could factor it out and have something that looks like that. But that's going a little extra. Okay. So next is a formula. A formula is an equation that states a relationship among different quantities. Formulas are special types of literal equations. Some common formulas are given on the next page. Notice that some of the formulas use the same variables, but the definition of the variables are different. So here are some formulas that you should have seen before, hopefully. If not, you'll see them definitely in geometry. And you should be able to kind of know how they use it, know how to use them and what they all mean. So perimeter of a rectangle. So that's P is equal to 2L plus 2W, where P is perimeter, L is length, W is width. Circumference of a circle, which we'll use next. C is equal to 2 pi r. Area of a rectangle. Area is equal to length times width. Triangle. Area is equal to 1/2 the base times the height. Area of a circle. Area is equal to pi r squared, radius squared. Distance traveled. Distance is equal to rate times time. And temperature. This one is commonly used when we're talking about literal equations, when we're talking about changing one thing to another thing. Celsius is equal to 5/9 Fahrenheit minus 32. Okay. The most typical kind of question for this is to solve Celsius for Fahrenheit. So let's actually do that because that wasn't one of the next questions. So if I wanted to solve this equation, 5/9 times F minus 32, if I wanted to get Fahrenheit by itself, well, the first thing I should do is clear this fraction. So I should multiply by the reciprocal. Okay? Those two cancel. And we have 9/5 Celsius is equal to the Fahrenheit minus 32. Adding 32 to both sides gives me that 9/5 C plus 32 is equal to F. So if I wanted a formula for Fahrenheit, I now have it. Okay? Where here we have a formula to turn Celsius to Fahrenheit. Here we have a formula to turn Fahrenheit to Celsius. Okay? Or Fahrenheit to Celsius here, Celsius to Fahrenheit here. Okay? So with these two equations, with these two formulas, it might be easier to be able to go to this one first instead of plugging a number in. Might be more efficient depending on the type of problem. Okay? Let's look at this problem. What is the radius of a circle? Well, you need to know this. The formula for radius of the circle. Oh, sorry, what is the radius of a circle with a circumference of 64? We need to know that. The formula for circumference, that has to do with radius. So circumference is equal to 2 pi r. 2 times pi times r. Okay, what do I want to know? I want to know the radius, so I can very simply solve this for r. So the radius is equal to circumference divided by 2 pi. Okay, which means this is going to be 64 over 2 times, use 3.14 for pi, and I should get my answer, which is going to be about 10.2 feet. Okay, round to the nearest tenth. Now, this is a type of question that it may not be simpler to do all this. We could have just said that 64 is equal to 2 pi times my radius and divide both sides by 2 times pi. And you'll still get the same answer, okay? So because this section was all about literal equations, right, we're always going to isolate the variable that we're looking for, but it doesn't necessarily mean that that is the fastest and most efficient way to solve it. Height of a triangle that has an area, a base, and a length. Base with a length of 8. So we want triangle. So the area of a triangle is 1/2 the base times the height. Okay? So the area is 24 and a base with a length of 8, and I want to know the height. So I could multiply both sides by 2. That'll cancel this 1/2. Divide by the base, and so we have the height is equal to 2 times the area over the base. So the height is going to be equal to 2 times 24 over 8. Okay, so we go 2 times 24 gives me a height of 6 inches. Okay? And if we wanted to, of course, we could have just plugged it into the formula that 24 is equal to 1/2 the base times the height and work that out that way. 1/2 times 8 is 24 is equal to 4h. Divide out the 4, okay, and we still get 6 inches is equal to the height. All right? Let's try a word problem. So, the monarch butterfly is the only butterfly that migrates annually north and south. The distance that a particular group of monarch butterflies travel is shown. So it starts in Indiana, goes to Mexico, travels 1,700 miles. Okay. It takes a typical butterfly about 120 days to travel one way. What is the average rate at which a butterfly travels in miles per day? Okay, well, if I think about my formulas, the one that's going to help me is distance, and that equals the rate times the time. Okay, and I want to know the rate. So that means divide both sides by t, and we have distance over time is equal to rate. Okay, well, distance, so my rate is equal to 1,700 miles over time, 120 days. And this answer, miles on the top, days on the bottom, this answer is going to be in miles per day. Miles per day. That's great because now I don't have to simplify anything. So we just take 1,700 divided by 120, and I get 14.16 round to the nearest mile per day. So this is going to be about 14 miles per day. Okay? Let's try one more. Pacific gray whales migrate annually from the waters near Alaska to the waters near Baja California, Mexico, and back. The whales travel a distance of 5,000 miles each way at an average rate of 91 miles per day. How many days does it take the whales to migrate one way? So distance is equal to rate times time. Now I divide out the rate because I want time by itself. So time is equal to the distance over the rate. The distance is 5,000 miles. The rate is 91 miles per day. The miles cancel out. We have over days, which means 1 over days in the denominator, which means it's going to go up to the numerator. So basically we have 5,000 divided by 91, which gives me about 55 days. Okay. All right, so solve each equation for the given variable. Solve this for y, so I would add 2x to both sides, divide by 5. Solve this for b, same thing, subtract a from both sides, divide by -2. Solve this one for x. Let's actually do that one real quick. mx plus 2nx is equal to p. So I want to get x by itself. Notice that it's in 2 places. They're both on the same side, which is good. So factor it out. M plus 2n is equal to p. And then divide out this whole expression, m plus 2n. M plus 2n. So my answer is p over m plus 2n. I knew this problem was popular. There it is. Solve for Fahrenheit. We already did that. So Jonah is planting a rectangular garden. The perimeter of the garden is 120 yards, and the width is 20 yards. So the formula then is perimeter equals 2 times the length plus 2 times the width. And we know the width, so now we plug that in and solve for L, or move this over to this side, divide out the 2, and then solve that. A formula, literal equation, or both? Well, this is a literal equation, has two variables. This is a literal equation. These two are formulas because I recognize them from formulas from my uh, list of all the formulas, and it states a relationship between two different quantities. Well, that states a relationship between C and D, but I don't really know what C and D mean. Here, I know what these two things mean. Okay. How's the process of rewriting literal equations similar to the process of solving equation one variable? Well, we're going to use the same steps, and they're pretty much the same in each case. You're isolating a variable, we're using inverse operations, but they're slightly different because in an equation in one variable, to isolate the variable, inverse operations are used on only numbers. When we use literal equations, it's used on letters and numbers. Like for this number one right there, right? We would add 2x to both sides instead of just getting rid of the negative 2. Instead of looking only at the numbers, we look at numbers and letters. Okay? And that was 2-5 literal equations and formulas.